discuss about transmission modes. While sending the data from one node to another node, we have to concentrate on, suppose if this is the sending node and if this is the receiving node, whether the transmission medium is wired one, that means there is a physical link is present between sender and the receiver node, or else in some cases the type of transmission may be wireless transmission. The transmission may be either wired transmission or wireless transmission. So one more concept we have to concentrate is whether we are sending single bit of information from sender to the receiver node, or else if you are sending group of bits, that means more than one bit from sending node to the receiving node. And in some cases what happens is there will not be a single receiver, there may be a group of nodes. From the single sender, a group of informations can be transmitted to more than one receiver. The transmission of binary data across a link can be either parallel or serial mode. So in the case of serial mode, single bit of information, that is one bit of information, can be sent along with each clock. But in the case of parallel mode, more than one bit, that means multiple bits can be sent with each clock. Well, there is only one way to send the parallel data, but the serial transmission can be subclassified as asynchronous serial transmission, synchronous serial transmission, and isochronous serial transmission. So the diagram shows different data transmission types or modes. The first category is parallel and the second mode is serial. Under parallel there is no subclassification, but under serial we are having three different classifications like asynchronous, synchronous and isochronous serial data transmission. So first we can take parallel transmission. So in the case of parallel transmission, we can transmit a group of n bits together. That means we can use n different wires. We can use n wires to transmit n bits. The mechanism for parallel transmission is very simple one, in which we can make use of n wires to transmit n bits. That way each bit has its own wire and all n bits of one group can be transmitted with one clock tick from one device to the other. So for example, if you are having 8 bits which is to be transmitted, 8 bits or 1 byte of information to be transmitted, we need to have 8 wires. The advantage of parallel transmission is speed. So in the case of parallel transmission, can also increase the transfer speed by a factor of n over the serial transmission. Because with a single clock, we can transmit n number of bits together, but in the case of serial transmission, we can transmit single bit in the given instant. So the diagram shows the parallel transmission mode. We are having the sender node and the receiver node. Suppose if we want to transmit the data pattern 0, 1, 1, 0, 0, 0, 1, 0. So here we are having around 8 bits are sent from the sender, but by sending we can send all the 8 bits together. And because of the total number of bits is equal to 8, we need to have 8 different wires. So that means we need 8 lines to transmit the data. So now next we'll take serial transmission. In the case of serial transmission, one bit follows the another bit. We need only one communication channel rather than n channel or n link to transmit the data between two communicating devices. So here we can observe that we are having the sender node and the receiver node. The data which is to be transmitted from the sender node is 0, 1, 1, 0, 0, 0, 1, 0. So we can observe that the one bit follows the another bit. In a sequence, the information can be transmitted into the receiver side. Here we need to have only one wire need to be considered here, and the information is received how exactly it is sent from the sender node. The major advantages of serial transmission over parallel transmission is only one communication channel is required. Here we need to have only one link or communication channel. The serial transmission reduces the cost, obviously. It is cost effective one of the transmission over the parallel by roughly a factor of n. But the speed of the transmission is less compared with the parallel mode of transmission. So the serial transmission, either it may be a synchronous serial transmission, synchronous serial transmission and isochronous serial transmission. The first subclassification under serial transmission is asynchronous transmission. The name given as asynchronous transmission, why? Because the timing of a signal is unimportant here. So in the case of asynchronous mode of transmission, we can group 8 bits together, and we can call it as a single unit. And while transmitting the data, we can maintain the gaps between the data units, as well as we can add stop bit and start bit. The data or informations can be transmitted together. We can group the informations into units, and we can add start bit and stop bit so that the receiver can identify the actual data, and we need to maintain the gap between the data units. So over here there is a gap between the data unit, here also there is a gap between the data unit. So instead of sending the data individually, so we can send group of bits together by adding some additional information like stop bit and start bit to each and every data unit. The receiver will receive the data and it will discard the stop bit and start bit, and it will get the original data. So this is how asynchronous serial transmission will take place. In the case of synchronous transmission, we are not maintaining the gap between the data or data units. In the synchronous transmission, the bit stream is combined into longer frames which may contain multiple bytes. So in the case of asynchronous, we contain a single unit, but here we are combining the units, combining the data units, multiple data units, and we can call such combined bits of streams as frames. So these frames may contain multiple bytes. Each byte, however, is introduced onto the transmission link without the gap between the data units. So here we can observe that this is one data unit, this is one more data unit, and so on. There is no gap between the data unit. So in short, we can say that in the case of synchronous transmission, we send bits one after the other without start as well as stop bits, or else also there is no gap between the data units. It is the responsibility of the receiver to group the bits. So in the case of asynchronous, we considered stop as well as start bit, but here there is no start as well as stop bit. Along with that, there is no gap between the data unit also. So it is a major responsibility of the receiver to get back the original bit stream from the frame. Advantages: obviously speed. So since there is no extra bits like start bit and stop bit in the case of synchronous transmission, and there is no gap between the units, the speed of the transmission will be more in the case of synchronous transmission, with no extra bits or gaps to introduce at the sending end and remove at the receiving end. Suppose if you are adding the start bit as well as stop bit to the data, this is the actual data. Suppose if you added start bit as 0 and stop bit as 1. But at the receiver side, once again, we have to remove that stop bit and start bit. So that is also the additional burden at the receiver side. So therefore, in the case of synchronous transmission, we can achieve better speed compared with asynchronous serial transmission mode. Isochronous serial transmission. In real-time audio and video, in which uneven delays between frames are not acceptable. That means synchronous transmission fails. For example, if the TV images are broadcasted at the rate of 30 images per second, they must be viewed at the same rate. If the image is sent by using one or more frames, there should be no delays between the frames. So in real-time application, the isochronous transmission, which guarantees that the data arrives at a fixed rate. So in the case of isochronous serial transmission, always the data arrives at the fixed rate, so that there will not be any delay occurred between audio and video signals. But in the case of synchronous and asynchronous synchronous transmission, there may be a chance of delay while transmitting the units of data or frames of data between sender and the receiver. But in the case of isochronous transmission, which guarantees that the data arrives at a fixed rate.